given a multivariate function is z is equal to 3x plus 11y whole cube upon 2x plus 6y. Find zx and zy, where zx is the partial derivative of this function with respect to x and zy denotes the partial derivative of this function with respect to y. So how do we solve this very question? So in this case we have to apply quotient rule, okay, because we have here, you know, this numerator and denominator, the functions are in numerator and denominator. We can use the quotient rule here. And what is exactly the quotient rule? Quotient rule is written like this. Let us say we have a function f of xy is equal to g of xy upon h of xy, okay. So as this function is being given, now taking partial derivative using quotient rule means f subscript x, okay. This denotes partial derivative of this function with respect to x, and it is being given by simply first we write this denominator function, that is h xy, and take the partial derivative of this function, that is gxy. Then we subtract and write this gxy as it is gxy, and then we take the partial derivative uh, with respect to x again of this function, that is h xy, and to this we divide by this h xy whole square, okay. This is the quotient rule that we need to apply, okay. So you will get this idea here. Now first of finding z of x. So z subscript x means taking partial derivative of this function with respect to x, okay. So let's give some intuition here. So first we write this 2x plus 6y as it is. So I will write it as 2x plus 6y, okay, as I have explained here. First we write this h of x, and then we take the partial derivative of d upon dx of this function, that is 3x plus 11y cube minus, then we write this gx again. So in case here our gx is 3x plus 11y cube, and again we take derivative d upon dx of now this function, okay, 2x plus 6y, and we divide it by hxy whole square. So this is our hxy, so we have 2x plus 6y whole square, okay. Very simple enough. That is, first we write this function and take derivative of this function, minus we write this function and take derivative of this function, and whole divided by this function, but it is square, okay. Simple stuff here. Now doing our differentiation here, we have 2x as it is, 2x plus 6y. Now derivative of this function d upon dx, I will write it here to make the things easier. Now d upon dx of 3x plus 11y cube will mean that we need to differentiate this function with respect to x. So first this will become, this exponent becomes quotient, as I have explained it so many times, plus 11y. Now 3 minus 1 is 2, okay, and exponent is subtracted by 1. Then we need to multiply, and since we have 3x again in the brackets. We need to take the derivative of this d upon dx of 3x. Okay, so we will get 3x plus 11y square, and internally the derivative of 3x is only 3 here, so derivative of x is 1, so we are left with 3 only. Okay, so this will become 9 3x plus 11y square. Okay, so the derivative of this stuff will become this. Okay, I have explained it here, so let me write it here. We have 9 3x plus 11y square minus, then we have this function 3x plus 11y cube, and derivative of this function with respect to x, since only one term is being here x, so derivative of x is 1, so we are left with 2 only, so we have 2 here. Okay, so I will write here 2. Okay, and derivative of constant is of course 0, so let's cut it short here. Then we have 2x plus 6y. Okay, very simple enough. Now what will we do here? We will factor out if there is any term like, so here we can see 3x plus 11y, 3x plus 11y, here it is cube, here it is square, so we can take square terms common, so I can write it like this: 3x plus 11y, I have taken it out. Okay, then what we are being left? We are being left with 9 2x plus 6y. Okay, then of course we have minus this 2 3x plus 11y. Why this is? Because we have taken square here, then one is left here, one term is left here. Okay, so this will be like this. So we have 2x plus 6y square here. Okay, now we have 3x plus 11y square. Doing some calculation here, so 9 2s are 18, 18x 9 6 are 9 6 are 9 6 are 54, so this is 54 54y. Okay, minus 2 3s are 6x minus 2 11s are 0y, and we divided by this 2x plus 6y square. Okay, let me rub this out. Okay, so we have here 3x plus 11y square. Now 18 minus 6 आधा वालों this is 12x. Okay, 12x 54 वालों जो 4 is the we have 2 here, 5 is the 32y. Okay, I have just subtracted the like terms. I have subtracted 6x from 11x and 22y from 54y, and I got this very stuff. Then we have 2x plus 6y square. Okay, can we do some further simplification here? Let's try to see. So we have 3x plus 11y square. Let's take 4 common here, so we have 4. We are left with 3x plus 4 8 are 32, so we have 8y upon, here we can take 2 square common. Okay, so let's explain it here. If we have this very stuff, 2x plus 6y square, I can write it like this: 2x plus 3y, okay, square like this. then I can give this square to each of these terms. So we have 2 square and x plus 3y square. So this is 4x plus 3y square. Okay, this stuff becomes this, so I can write here 4 x plus 3y square. 4 and 4 gets cancelled, so we are left with 3x plus 11y. Then we have 3x plus 8y. I hope I am making the calculation right here. And we have x plus 3y square. Okay, so this was our zx. Okay, so similarly we can find out zy. Okay, let me try to find out zy also. For that I have to rub this out. Okay, so da, 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 da. So let us write it here. Now we need to find out z subscript y. That means partial derivative of this function with respect to y. Okay, so this will remain same, but we have to take partial derivative with respect to y this time. Okay, so we have y here, we have y here. Okay, simple stuff. How do we do? Use the quotient rule. First we write the denominator this function and take derivative of numerator minus numerator function the derivative of denominator function whole divided by denominator function square. Okay, simple stuff. Now using the same stuff here, so we have 2x plus 6y as it is. Now derivative of this function as I have explained it here. So first we need to take the power function rule. That means 3x plus 11y. 3 minus 1 is 2, so this becomes square. So first we use the power function rule, then we have to internally differentiate with respect to x. So derivative of 3x is 3, so we multiply it by 3. Okay, then we have minus 3x plus 11y cube. Derivative of 6y will be 6 because no y is involved in this term. Its derivative will be 0, so we are left with 6 only. Okay, sorry, no, sorry, I had a mistake here. We are taking the derivative with respect to y, so here we have to internally differentiate with respect to y, and derivative of y is 1, so we are left with 11. Okay, it was an horrendous mistake here. Then we have 2x plus 6y square. Okay, now we can do one thing here. We have 11 threes are 33. Okay, so we can first take this 3x plus 11y square common. Okay, then we have 11 threes are 33. We have this term 2x plus 6y minus 3x plus 11y. So let's write this 6 here. Okay, divided by this term 2x plus 6y whole square. Okay, now we have 3x plus 11y whole square. I am okay, this is 2x here. So what we are being left here, let us take 3 common here now. Okay, if I take 3 common, we are left with 11. 2x plus 6y minus 3 11s are 33. 3x plus 11y. Okay, I have taken 3 common, whole divided by 2x plus 6y square. Okay, I hope the calculation is going right. At times there can happen some horrendous mistakes in my videos obviously. So So let's write this 3 here. We have 3x plus 11y square. I have just written this 3 here because we know multiplication is commutative. So the cube is here. Now 11 2s are 22, 22x plus 66y minus 6x minus 22y, 22y. Okay, I have just multiplied this 11 to each of these terms and this 2 to each of these terms. So 11 2s are 22, 11 6s are 66, 2 3s are 6, 2 11s are 22, whole divided by this 2x plus 6y square. Okay, so we have we have 3x plus 11y cube. Now 22 minus 6 comes out to be 16x. Okay, now shorten values do that is 44y divided by 2x plus 6y whole square. Okay, now we can write it like this. We have 3x plus 11y. It is square here. Okay, I am doing again the mistakes. So we have square here, so taking 4 again common, so we have 4, we are left with 4x, this is plus, my mistake, we have 4x plus 11y upon, here we can take 2 square common, so this becomes 4, 2, as I have explained it becomes x plus 3y. So okay, this 4 and 4 gets cancelled, so we are left with, let me write it here. Okay, so then we are being left with 3. We have 3x plus 11y square into this 4 gets cancelled, my mistake, this 4, so we have 4x plus 11y and we have x plus 3y. Okay, and we cannot solve it further. This is the simplified form of these very expressions. Okay, so zy comes out to be this expression. Okay, I hope I make myself clear in this video. Thank you.